In today's video, we're going to explore the most well-known statistical distributions. Being able to differentiate between various statistical distributions is particularly important for setting up appropriate hypothesis tests. Let's start with the most famous statistical distribution, the standard normal distribution. The standard normal distribution is recognizable by its characteristic bell curve and symmetry. Most of the observed values are concentrated around the mean of the distribution, while values that deviate more from the mean become increasingly rare. Outliers can thus be found at the tails of the distribution. Because of its symmetry, the location parameters, mean, median, and mode, are identical in the standard normal distribution, and are exactly at the center of the distribution with a value of 0. The variance of the standard normal distribution is 1. Next, let's move on to the so-called t-distribution. Visually, the t-distribution resembles the standard normal distribution. However, the curve of the t-distribution is wider than that of the standard normal distribution. As the sample size increases, the t-distribution approaches the standard normal distribution. The t-distribution is particularly used for smaller samples. Since the t-distribution is also symmetric, it has a mean, median, and mode of 0. However, the variance here is greater than 1. Let's continue with the chi-square distribution. The chi-square distribution is characterized by its steep rise and subsequent flattening of the curve. The chi-square distribution is used in various statistical tests. For example, tests based on the chi-square distribution can be used to derive variance. Unlike the standard normal distribution or the t-distribution, the chi-square distribution is asymmetric and only takes on positive values. In connection with the chi-square distribution, we also talk about degrees of freedom, which indicate the maximum number of independent values that can vary in estimating a parameter, such as variance. Higher degrees of freedom are associated with a larger sample size. The expected value of the chi-square distribution is equal to the number of degrees of freedom, and the variance is equal to the number of degrees of freedom times 2. Perfect. Let's move on to the last distribution, the so-called F distribution. The F distribution is visually similar to the chi-square distribution, but differs due to its sharper shape. Various statistical tests can also be performed using the F distribution. Particularly important is the F-test, which is used to examine the variance values of different samples to determine whether they come from the same population. Alright, that's it for the most well-known statistical distributions. We hope this video has helped you understand the topic of statistical distributions. See you next time and have a good one.